Am I far enough away to take this mask off? Is this okay? Is everyone okay with this? If not, I can leave this on. Okay. Like I said, I've been in this for about 32 years. We started selling heat pumps back 20 years ago. I kind of saw this was a good technology and what I was going to see. I kind of believe now what really did happen, and it's really taken off right now as far as what's going on. I'm seeing programs in New York, Connecticut, Boston. I just heard the other day that Mass Save is allocating $4 billion to the program in the next 3 years. So I think we're going to see, I actually have a meeting on Monday with Mass Save on rebates for next year for 2020. So I think we're probably going to see an uptick in rebates. So I don't have full information on it yet, but as soon as we get that, we will get that to you, which is a good thing that they're doing it now in November. Usually sometimes they don't tell us till February. And it's like, okay, well, what about the people from January? So anyway, so we'll buckle our seatbelts with that and we'll take case. So we are doing this on Zoom too, so we have about 25 people on Zoom that are working with us as well that couldn't make us. So I want to thank those people from joining us. They're going to direct their questions to the chat and we'll have them join in afterwards if need be. So they're going to be muted throughout the seminar and they won't be able to get in. So. Just some quick housekeeping things. So there are men's and ladies' rooms downstairs if you do need to use those. All right, so why should I consider heat pump technology for my home? Why would I want to put this into my home? So a lot of people ask us that a lot. You know, you look at just what's happening with the grid. We look at electric cars right now. We look at the electrification of the grid and what we're trying to do. I even heard part of that $4 billion is to improve the grid too, to get the grid a lot smoother and bring more power in as we're doing things, because as these things happen, we're going to need more power. So that's definitely part of it. You know, when we kind of look at the way things are, it's definitely a greener way to heat your home. When we demonstrate this, you know, we look at how things are being done, and we look at the way things are now with solar. I mean, I was down in Chelsea the other day, and the whole top of the New England Produce Center now, 4 buildings, is completely solar.
That's great.
And they're renting the whole roof to the city of Chelsea. And there's just hundreds and hundreds of solar panels up there, what they're generating electricity for. So a lot of the actual walk-in coolers and heating and cooling that, you know, your food that's coming to all distribution centers, to the supermarkets and stuff, a lot of it is being produced by solar power now. So, and there's a lot of electricity down there. But, you know, when we look at the United States, and we look at how we do things here and how heat pumps work in the United States. I don't know if anyone's ever traveled the world, but you go overseas and that's really all you see. I mean, I was in Italy a couple of years back, and every hotel that we went in had a heat pump. Nothing was gas, nothing was oil. You know, when you travel around, this is how it is, but the United States is just very, very far behind at how we did things, because we have oil, we have gas, we have electricity, but we have propane to heat and cool, to heat and cool our homes with electricity, obviously. But I heard the other day natural gas is up 100% in cost. Oil, obviously we see gas prices rising, things are going to happen with that. Propane is up in price. They're commodities and they go up and down with what happens. But the heat pumps is definitely not a big part of the United States. We are seeing this come fast and furious. Mitsubishi Electric just this year turned $1 billion in sales. So they were at 500 million 5 years ago, and they've just turned $1 billion. So this is how fast things are growing with this product, and how people are doing things in buildings. So when we look at how we use energy in our homes, 45% of it is used on space heating, 18% of it is used on water heating, space cooling, 9% on cooling electronics. But this is how we actually use our energy. And, if we look at it, over 50% of it is being used for water, heating, and cooling. So I want to just kind of look at the product in the past and the present and what we have today. When you look back at an air source heat pump, I'm going to identify it as an air source heat pump because that's really what it is. A lot of people call them ductless units, mini splits, all kinds of things. It is really an air source heat pump. So when we look at the outdoor unit that we have over here on the floor, we have one outdoor unit and one indoor unit. That's what it's comprised of. And that was the past. We used to have one indoor unit, one outdoor unit. They were ductless only. You couldn't put ductwork on them. They were always used for spot cooling. They were never used for heating because they really didn't heat that well. After, below 32 degrees, you really weren't getting a lot of heat out of them. There was a lot of niche applications. There was little product awareness to what was actually happening in the United States with it. But now, when we look at the present, we fast forward 20 years. I can remember this back 20 years ago, 25 years ago, that this is what we sold. We were into the sunroom addition type thing, very niche type thing, garages, things like that. But now, 80% of what we do to 85% of what we do is a whole home solution. It is a whole home solution. This system will heat your home, and it will also cool your home very nicely. The biggest part about it is, the present is that everything is zoned. When you go into a home, I want you to think of this. When you come into your home today, if you had a switch in your home and you walked in the front door and you just turned it on and everything came on in your house. Your lights, all 5 burners. If you had an electric stove, all 5 burners came on. Every light came on, every outlet energized. Anything that you had that was electric, everything came on. It's kind of how we heat our homes today. We have one thermostat that might be on the first floor, one thermostat on the second floor. We don't have a lot of zoning. We don't, whoa, what just happened? We don't have a lot of comfort. When you look at this, we have a variety of different things of what we can do, where we can have one unit off, one unit set at different temperatures. We have all types of different indoor units, like I was showing you, ceiling units, ducted units, full ducted units, however we want to put that together. But the biggest thing is it's a whole home application. Can be done in whole homes. We do it every single day, and it definitely works, and we have done that. So here's the biggest difference: is it's a zone comfort solution products now is what happens with it. So when we move forward a little bit more on the HVAC side, and we look at how electricity is used in our homes, 50% of it is spent on HVAC. Air conditioning in the summertime, heating in the wintertime, space heating, electric water heating, lighting, appliances. Gives you just a good idea of where the consumption's going. You think of the summertime in Boston when everyone has their air conditioning system on. How much electricity is being consumed? A lot of it is being consumed. That's why the grid is going to need a lot of work over the next 20 years. It's not going to be able to handle what we have. So there is big money being spent for improvements on that. So heat pumps are definitely part of this solution of what we're trying to do to consume less energy. Because a lot of that equipment that's being run today is super inefficient. And I'm going to show you some of the efficiency parts of it. So a basic refrigeration cycle, or basically what happens in a heat pump, is in the wintertime, or in the summertime, we have cold air that blows out of the indoor unit and warm air blows out of the outdoor fan. If you're outside buying air conditioning in the summertime, you feel if there's warm air. Well, that's the heat that you're removing from the space inside. That's what's actually happening there. In the wintertime, it's just the opposite. The warm air is going inside the home that was coming out. There's a valve that just changes over. It just says, hey, outdoor unit become the indoor unit, and indoor unit become the outdoor unit. And so now you're just reversing the heat cycle is what happens. So you have a compressor in that unit. You also have a coil in that unit. And basic refrigerant, warm refrigerant, gets pumped out of that unit, gets pumped through the indoor unit, and it comes back, and it goes through the outdoor coil, and it comes back in and just goes through a big cycle. It's just a big pump that's in there, and it's just compressing refrigerant and putting it back. In the summertime, the cool part goes in here, and the warm part comes out here. So it's just a reverse cycle is all an air source heat pump is. A heat pump is an air conditioner with a reversing valve in it. That's all it does. It just switches it around. So I want to talk a little bit about a standard compressor. This is what about 95% of cooling systems that are out there now. This is let's consider this a central air conditioning system in a home, okay, that people use today. It basically is an on-off system. So what it does is the compressor. Degrees in here, it's 64 degrees in the bedroom. I'm not even in the bedroom. I'm wasting all kinds of energy to get one room cool. But the biggest thing I want to show you here is the 60 hertz. That's how we provide electricity in the United States on hertz, 60 hertz. You go overseas, it's 50 hertz. Sometimes it's different in different parts of the country, but the uncomfortable and the high usage. I want to show you how an air source heat pump runs, okay? It is not an on-off compressor. It is a compressor that basically doesn't pump, it doesn't have pistons in it, it spins. It's a scroll compressor that spins, all right? And it speeds up and slows down on demand, all right? And the faster it goes, the more current it draws. I'm sorry. Shut this off. I meant to turn this off. That was very rude. Sorry. So that speeds up and slows down. So I want to show you what happens when this starts. It doesn't spike up to the 60 hertz. It starts at 0 hertz and it comes on. We'll show it to you after the seminar. We'll turn one on and show you. And it basically starts to just use a few hertz. And as the compressor speeds up, it goes up to about 130 hertz. And the temperature pulls down quick, because the faster we run the compressor, the quicker we can get the heat out of the space or get the heat into the space. And as we start to reach room temperature, we start to slow down and we get below 60 hertz. We can run down as low as 30 hertz. Half of what I was showing you prior was 60 hertz, was something that could run in the American industry. But a lot of this is like, consider this, city driving and highway driving. On-off compressor is basically like city driving. You put your foot on the gas, on, off, on, off, on, off. This is more highway driving. I pull out onto the freeway, I rev it up, and then I get out onto the freeway, and I just deaccelerate and run at a lower fuel level. Very similar to that, very efficient. It adjusts to the speed of the room. So when the room says, hey, I'm within 3 to 4 degrees of room temperature, the compressor starts to slow down, all right? And it starts to just give you the amount of heating and cooling that it needs for the room. It doesn't really turn off, it just speeds up and slows down. And you can actually hear it in the outdoor unit. The outdoor unit will, it's like a turbine, it'll go up and then it comes down, depending on what you need in your home to heat or cool that home. So, we've heard a lot of myths about heat pumps not heating and how they don't work. And you know, this is an actual temperature chart of Boston 2 years ago. All right, it's a little bit of an outdated slide, but this is based in hours, okay, in temperature, annual hours and temperature. So when you start to look at our temperatures of how many hours and what we have, and we look from 20 degrees to 49 degrees, a lot of those hours, a bulk of those big hours, are from 30 to 39 degrees. When you look at how things are going to operate. So, you know, we do have some cold days, but this is really at nighttime. This is at nighttime. So when we start looking at the days when the sun comes out, you know, it really gets up there. So even, you know, when we start looking at hours above 90 to 99, and, you know, all this was done at Logan Airport. So, you know, some summers we don't have real extreme hot summers, we have a lot of humidity, but this is all based on hours and temperature. But where I want you to kind of focus is right here. I want you to look at these 3 bars, these 2 especially, because this is where we are super efficient, super energy efficient right here. So when we look at heat pumps versus fossil fuel, all right, and again, a lot of this was done 2 years ago too with the prices of how things were operating. So to create 1 million BTUs of heat, okay, to just create 1 million BTUs of heat with electric resistance heat at around 20 cents a kilowatt, which we know has gone up, okay, is around $53. Oil, this was based at, I think, around $3 a gallon right now. That was about $27 to $28 to create 1 million BTUs. Propane, we know, has gone up in cost. Now I want you to look at these COP numbers, all right? And then we've got gas in the middle there, on the second to the right there. COP is the coefficient of power. And the way that we rate our heat pumps is by how fast they're running. and where they run. All right, so the higher the temperature, the more efficient it is. So when we're around those 30 to 40 degree days, we're running at around a COP of 4, in between 3 and 4. So you can see we're just as efficient as gas at this point. When we get cold out, we are going to run at a lower COP. A lot of this is based on how well your home is insulated and how tight the envelope is. If you've got leaky windows, you've never done any insulation in your home, if you are considering putting a heat pump in your home, I highly, highly recommend getting a home energy audit, looking at your windows, looking at your insulation values, because if the house isn't insulated, I don't care what kind of heating system you're going to put in it, it's all going to leak to the outside anyway. Warm air goes to the cold. So if we have the house at 70 and it's 0 degrees outside, all that warm air that's in here is going to leak to the outside. So it's kind of like if we put an ice cube on the table, it will melt because the warm air will go to that. So focus in on these numbers and we'll talk a little bit about them, but Mitsubishi Electric makes heat pumps that do heat when it's extremely cold. We actually have a heat pump right now that's 100% efficient at minus 13 degrees. What do I mean by that? If the heat pump actually says it will produce 18,000 BTUs, it will produce 18,000 BTUs at minus 13 degrees. All right, or very, very close to that. Might be maybe a couple hundred BTUs off, but the variety of them, the most part of them, they heat at around 5 degrees. They're 100%. And as I showed you on that chart earlier, there aren't a lot of days that are much colder than 5 degrees in the Boston area. So when you look at the unit, you're going to see these tags on them. See those red tags that say H2I? That's what's called a hyperheating system, okay? You're going to hear me say that a lot. But when you look at some of the other systems, they don't have that logo on there. That's a standard heat pump, okay? So that means, what do I mean by standard and hyperheat? There's two different versions. And a lot of times people get caught up in this when they're looking to buy a heat pump. I mean, this just happened to us last week where a competitor had actually sold a heat pump to a home, different brand, whatever it was, and it had the heating capacities at a low temperature, okay? I mean, it could heat, but the unit had to be oversized to have the amount of heat because at a low temperature, it wouldn't produce the amount of heat that it was trying to get, so they made the unit bigger. So in the wintertime, it would work to put that amount of heat in there. But in the summertime, it's extremely oversized for air conditioning. It just runs and shuts off in 10 minutes. So what happens? You don't remove any of the humidity from the home. So now the home is cold and wet and clammy because the system's too big. So that's the importance of kind of when you start to look at things and how you put things together. So this system will actually heat at the low temperatures and give you the amount of heating and cooling that you need to do what you're trying to do in your home. All right, so how does it work? All right, because a standard heat pump will only give you a heating efficiency at about 32 degrees. So if it's standard and it doesn't have an H2I logo on it and it's not what we call a cold climate air source heat pump. I don't care whose brand it is, you have to make sure it's a cold climate air source heat pump. And you want to look at the specifications on it. And the biggest thing you really want to focus in on too is what are the COPs of it at the outdoor operating temperatures? Okay, because some of these can get very expensive to operate if you don't have the right piece of equipment. So as the outdoor temperature drops and you need more heat, the compressor is going to speed up. I showed you that earlier. Okay, now as the compressor gets hot, okay, we're going to add refrigerant to cool the compressor off, and we're going to grab that heat and we're going to use that heat inside the home. So when that compressor speeds up, we're going to grab that heat and use it in the home, add it to the refrigerant, and get that warm air into the home. So when you feel that unit, when it's 5 degrees outside, it's going to be pumping out 120 degree air out of it. 120 degree discharge air temp is usually what's going to come out of that. But this is the logo you want to keep your eye on. And if you look in your books, there is some literature that we did put in there. You always want to make sure whether it's, if it's LG or Daikin or whoever that manufacturer is that you might be looking at, you want to look at the capacities of what the system will give you at 5 degrees. Because you could see at 5 degrees, a 12,000 BTU unit might only give you 6. You want to make sure it's 12 and 12. That's where you're going to see the cold climate heat pumps, okay? So why does hyperheat matter when you start to look at heating your home? At 47 degrees, a conventional heat pump, they'll both give you 100% capacity, all right? At 23 degrees, well, look what happens. It's 100% capacity with that. It's 60% with a regular heat pump. All right. Now get down to 17. We're still at the same numbers. At 5 degrees, look what happens. Now you're not getting any heating capacity out of it. This is where basically it's just, I don't know if anyone's ever experienced an old heat pump in maybe an old condominium that you might have owned from the 80s or the, maybe late 80s, early 70s, where it was backup electric heat they used to put into the system. Basically, that's like putting a toaster oven in your ductwork. All right, and we know that's very expensive to operate because that's pure electric heat on all day long with a fan running over it. Probably the most inefficient way to heat and cool, inefficient way to heat a home. At minus 13, you're going to see 0% capacity. Some of the hyperheat systems at the 5 I was telling you about, they're going to get 76% capacity. So you can see you can still heat with this heat pump. It's a myth. Those days are gone. So some of these acronyms that you hear about, that I've been talking about, COP, HSP, these are some of the other things that you really need to consider when you're looking at buying a heat pump for your home, all right? Because this is where things get caught up in cost and price, and people don't understand what it is and what the SEER rating is. So SEER rating is the seasonal energy efficiency ratio, all right? That's the cooling output during a typical cooling season, and the higher that number, the better off you are, okay? We are videotaping this too. We're going to send everybody out the videotape after this, so if you wanted to go back and watch something, you didn't think you remembered something, you'll have the ability to see that. So this is 13. 13 is the lowest number that can be sold in the United States today. 13 is the lowest. That is the least amount that manufacturers have to make today. Our systems on the low end start at around 20. I've seen some as high as 35 to 40 from all different manufacturers. So the higher that number, the better. So when you're looking at purchasing one of these, 13 is bottom line. That is like the lowest efficiency heat pump you can possibly buy. All right, and it's probably going to be the cheapest one you can buy too. Okay, and it's going to consume the most energy out of all the ones you're going to buy too, and it's going to cost you the most amount of money to run in an HSP to get these rebates. So again, the higher the number, the better. This one has to do with heating. These two you're going to get into heating, all right? So the HSP, this is the heating seasonal performance factor. Again, the higher the number, the better, the HSP. And a lot of these numbers, they're hidden. You got to kind of dig for these. And the better these numbers are, the more efficient the heat pump is. And you got to look at this because the cost factor could be less from a different manufacturer or a different contractor or whatever they're trying to sell you. Is you got to make sure that these numbers are falling in for rebates and for your energy efficiency purposes, all right? The COP, again, the higher the better. This is the ratio of heat supplied or removed from a system divided by the electrical energy supplied at a fixed state. I'm not going to get into that and how it all works. But again, the higher the number, the better. When I showed you COP at 4, you saw how the cost of that was a lot less to run. Okay, so if you're getting COPs at 5, I don't think you're ever going to see one at 5, but 3.9, 4 is really good. So again, these numbers are really, really important when you start looking at buying a system. When you start looking at COP and an average COP, what are some of these numbers of heating equipment? So boilers, direct heat, you can see they're in the ones. Electric resistance is 1 to 1. A standard heat pump is 1.86, and a mini split with zoning on it is about 3.7. So you can see the efficiency ratio is pretty high at those higher temperatures. So let's talk a little bit about the systems now and how they operate and what's involved with them. So from a sound level, units are pretty much sound. You really can't hear them. If you looked at a human whisper, it's about 30 decibels. GL12, which is probably that unit right there, that head right there, on low-speed fan runs at 19. So you can probably pretty much not even hear that run. I'll turn it on in a second and you can hear it and hear what it sounds like. You know, when you look at some of these other ones, a lawnmower, a blow dryer, it gives you an idea of the sound decibels of what happens. A KJ12, which is this unit right here, that's an actual floor mount unit. That's that unit right there. That unit mounts down low in your home. Okay, so that goes down onto the floor side. So that's a floor mount unit. Again, 21 decibels, 46 on high. When you look at a Frigidaire window unit, when a window unit's running with the compressor on, it's at about 63 decibels. Put the window unit in the window, you kind of, oh, turn that off. I can't hear the TV. I can't hear what's going on. So again, on and off, on and off. So let's look at some of the residential M-series units, okay? Where mostly everything we deal with in residential is called M-series, right? There is a P-series. We do use some P-series stuff with some ducted units and some condominiums and stuff like that, but we're going to stick with the M-series today. So you have this is FS now, right? FS unit, which is that unit above your head right there. All right, a little bit that's an FH, but this is the newer model, the FS that's out now. High efficiency indoor unit, okay, you can see it's a little bit different than most of the units that you look at today. Compared to this unit, a little bit different. It's got a couple blades on the bottom, it's got a double fan in it. Got a lot of different features inside of it, a little bit different filtration inside of it. It's got this little sensor on the bottom right here that kind of looks around the room. It says, is anybody in the room? It can basically divert air away from you from indirect to direct. It's got a lot of smart features on it. It's our highest efficiency indoor unit now we have today. We have the KJ floor mount unit that goes down low. This can be recessed into a wall if anyone's building new construction or anything like that. This unit can be set into the wall about another 2 inches, so it only sticks out 4 inches. So this part can be set into the wall. I've had some people do that. So that can go down low. You have the SEZ unit, SUZ, right? SUZ? SE. So this is a ducted unit with not a lot of static pressure. It's this unit above my head right here. This is used more for like a 1-bedroom with a bathroom or something like that to create one zone in a very small area. Put ductwork on the front of it, put some white registers like the round registers you see above the ceiling or square registers, whatever, and that takes care of that one space. This right here is a ceiling recessed unit. Okay, that's the unit above your head right here. This goes between 14 on center, sits right up into a hole, and bounces flush with the ceiling. It's a one-way blow unit. It's an MLZ unit. Right, so that can go right up into the ceiling. Good for bedrooms, etc., things like that, one zone type system. This unit here is a 4-way blow, goes in a 2x2 cassette right here. That can fit into a ceiling too. You'd need to do some carpentry work to do that, but that blows out 4 ways. Sucks in the middle and all 4 of those little side vents there is where the air blows out. Then we have our standard SVZ unit right here that basically has ductwork that you can put on it. It's this unit right here. This replaces a basic central air conditioning system, can do the whole floor of a home. Ductwork can be tied onto it, can go in the attic and a basement. It has electric heat backup. If you wanted to put it in, you can put it in. Don't really need it, but this is how this would go. And it's really built very, very, very well. Thermostat controls can either be wall mounted or handheld as well. So that all kind of goes together. Everything that you see here can go on to a one-on-one system. What do I mean by that? That can have one compressor and one set of pipes that go between it. So you can take this outdoor unit right here and put the pipes and the line height, everything can go with it, and it can be attached to that. It can be used in any type of a single zone application. This is what we call also a single one-on-one. This is exactly what I just meant. One outdoor unit, multiple different types of indoor units you can put with that. All right. Now we'll get into the multi-port type unit. All right, so this unit here, the most amount of indoor units that you can put on an outdoor unit without this branch box right here, that I'll get into in a couple minutes, is 5. Okay, you can put 5 heads on that unit without any branch box. This does not come in hyperheat when you get to 5. You can do it with 3 without a branch box. When you get over to 5, it'll be a standard heat pump that will not give you the high heating capabilities. But, however, if you just needed to run 1 or 2 units with this in the wintertime, you would be able to heat with that, because if this was, say, 42,000 BTUs, this would give you about 24,000 BTUs full in the wintertime at the low temperature. So you could use 2 units to heat with that. A little bit, I know it might be a little confusing, I can talk a little bit about that after, but this is the multi-port system, okay? Where we put what's called branch boxes in your home. That's that silver box right here. And you can put 2 of these branch boxes in your home. They have them in 5 ports, which you can do 5 indoor units off of it, or 3 ports. So usually we do a 5 and a 3, or sometimes 2 5s. We're showing it here with 2 5s. All right, and you can do 8 indoor units. If you were going to do 8, you couldn't use a 3-port box. You need a 5-port box to do 4 units. But this gives you an idea of how you can break it up in your home. You have the 5-port branch box, you have 4 indoor units. And you can see all 4 indoor units are a different style. You have ducted, floor mount, wall mount, ceiling recessed. And over here we have the 4 wall mounts. Okay? All kinds of variety, as you see, in what you can do with the system. It's not just, when we went back to the past and the present earlier, and I showed you, it was like, okay, just one-on-one type situation. It's a little bit different now. Let's talk a little bit about the different controls of how you would control those indoor units. You got a standard handheld remote control, cooling, heating, fan, very basic, very simple. Comes more with this remote here, would come more with our low-level units. Very simple, couple of basic things on it, nothing crazy. Now you can get into control options where you have an MHK2 controller that looks, it's made by Honeywell for Mitsubishi. It is a wireless thermostat. It has no wires between the indoor and outdoor. It works off this sending unit right here, sends the thermostat a signal, and that can be used with everything. It has wireless red link in it. Can be tied to Honeywell's things too. It's got Fahrenheit, Celsius, and you can use that on pretty much any indoor unit that we sell today. Okay. A lot of people ask, hey, can I use my thermostat with our unit? I have Nest, I want to use Nest. Or I have, Flare Puck, or whatever I have for a thermostat, and I want to use my thermostat. You can use it. That you do need a transformer, and you do need an interface, and you can tie it into it, all right? It's a little bit tricky, but it can be done. You can use the Pro Series. A lot of people more want to use this if they're going to use a ducted unit, not really a wall mount unit. A lot of people will go to that if they have their own thermostat. So, how do things work from the web, and does it work with Alexa? Yes, it does. You can tell Alexa what to do with it. You would need your Kumu clouds put in here. This is a little white box that goes inside the unit. We actually have one right here. You can see it's sending off a signal. That would go inside the unit, okay? And that would be programmed to your smartphone. You do need Wi-Fi in the home. You do need a good router that will send a signal, all right? And that can get put onto you put one of these in each indoor unit, and you would have all 5 of them show up in your home, all right? So everything would show on the phone, then you would go and click with what you need from there. So we'll talk a little bit about this. I'll get into this in a minute, but integrated controls. How do we integrate a heat pump system with our existing system? Say you had a gas system and you wanted to integrate heat pumps into it, or you have an oil system and you want to integrate heat pump into it. What do I mean by integrate? I want to be able to use the heat pumps to heat my home with a heat pump that doesn't heat below, say 17 degrees. I want to buy the cheaper heat pump that I don't have the full heating capacity with, and I want to run my heat pump. I would integrate a control package into this that my air source heat pumps would heat above, say, 28 degrees. Below 28 degrees, my oil system or my boiler or whatever I have would run in my home. We would add some controls in there. We'd add a Kummel cloud station in there. There are a bunch of different ways to do this now, where this basically simulates your boiler. This tells us your boiler's on below a certain temperature. It would shut your boiler off. So that's how that would work. I'm going to get into that in a minute, but this is where Mass Save picks up a lot of their rebates too. I'm going to get into that, the rebate side of that in a minute, especially if you have oil or electric heat in your home, okay? So we stage it out. This is showing us how it's staged out at 30 degrees, okay? So, single zone units, but this could be 5 zones. This could be a 3-zone unit right here with 1 compressor with 3 indoor units. This could be 1 compressor with 2 indoor units. This could be 2 compressors with 2 indoor units. It all depends on how the home lays out. A lot of it has to do with pipe lengths, how far. I can only run about 82 feet from that indoor unit to either a branch box or an outdoor unit with most MCs. So we have to have some restrictions with pipe. This shows this kind of broken down into 3 zones with 2 single zones, just kind of giving the idea, same home, different colors, okay? So let's talk a little bit about the installation side of it. How does the installation go? What happens in the installation? What should you expect the day of installation? What's going to go on? It's a 6-step process. You're selecting locations where things are going to do. You're installing indoor units. You're installing outdoor units. You're interconnecting the system. You're leak testing it with nitrogen. You're charging it with refrigerant. And then you're testing the system to ensure that it's working properly after everything is installed. So, you know, day 1, you would see guys measuring walls, or not even day 1. This would happen way before the installation actually happened. That would be being done by a comfort consultant. And then indoor units are getting hung. You can see that's the high efficiency unit he's putting in there. Hyperheat system going on the outside, setting that in. They're connecting refrigerant lines between the indoor and outdoor units. One thing I really want to point out to you is there's a certain torque mechanism. You can see the special tools they're using here to do this. They're not just tightening that up with wrenches. There's a lot of certain specifications that go into this system when you install it. Everyone always says, look, I can just go buy this on the internet and I can have someone put it in for me. I always say to people, well, make sure they have the right tools, because there's some certain tools you're going to need. You're going to need some refrigerant gauges, torque wrenches, vacuum pumps, nitrogen. I could go on and on. Recovery machines, vacuum pumps, all kinds of things. So again, some special tools you're going to need to do things. And you can see the testing purposes of what's going on. He's testing temperature, he's testing humidity, he's testing the senses, because a lot of these things need to get done so the Mass Save rebates can get handled properly. A lot of times contractors can't get you the rebates if they don't have the right paperwork to do everything, or they might not be in the program to do things. So again, why is it important to choose the right contractor when you do this? Okay, this is an actual job. Huh?
It's a real job.
It's a real job. It's a real job and a real home that somebody paid for.
We did not do that.
We did not do this. We did not do this job, but we fixed this job, okay? But just, this is, I mean, seriously, this is some of the stuff we see day in and day out, okay? You're going to spend a lot of money. I would think that is not what I would want in my home. I don't think anyone in this room would say, I don't even know how the homeowner could actually say, yeah, and give you a check for that, but somebody did. So none of it's up to code. You can see you got multiple connections in here. We got oil traps all over the place with refrigerant. We've actually got extension cords being run here. It's just a mess. I mean, this is what the outside of your home should look like. This is how things are done. They get put up on stands. They get kept out of the snow. All piping. You can see some of that piping isn't even concealed. You can't even see some of it. It's in the back. These are some homes that we've done some installations on. So you can see, yes, there is a plastic system that has pipes that go in between it. But you can see this home in Rockport we did, you know, granted this is the front of the home, but you can see there's the line hide running here. It's white, it's tan. It switches over to white on here, goes back to tan, comes down on the outdoor unit sitting here. You can see this unit here, the white is being followed by the electrical pipe outside. There's another white here matching the outside of the house. A lot of it is done in the layout. The layout and the design is so important when they come out to your home, when you know, Chip or Jimmy or Dave or these guys come out, they're versed in layout. You're going to see a layout of your home before it's done. It'll all be drawn up on company cam, they'll have lines going down it, everyone will see the layout, you know, agree on the layout. Okay, this is where things are gonna be placed. This is how it's gonna be done, so there's not that surprise that I showed you earlier. Okay, we don't want that. That's not what we want. We want to do it right the first time. All right, so some case studies. I'm going to start winding down a little bit of some things we've done. All right, so this is a Newburyport Cape. Converts this with propane to ductless. Okay, cost of the system was a 5-zone Mitsubishi heating cooling system. It was about $18,000. This was a Mass Save $500 rebate. But what they used here was a 0% 7-year interest, the loans. If you haven't seen Mass Save heat loans, okay, we're going to talk a little bit about them today and a little bit about the PATH program. If you are not a municipal, you know, you buy your energy from National Grid, Eversource, etc. There are 0% loans for 7 years that are out there through multiple small banks in Massachusetts. We use a lot of what's the one? Hanscom Federal Credit Union is one of our favorites. We like because during COVID it was one of the only ones that you could do completely online. And it's still that way today. You don't need to go into the bank. Everything is done online with them. And it's about a 3-day turnaround most of the time. So they're very, very easy to work with. Annual savings on this home was around $2,500 with the propane heat and the window air conditioning units that they took out. All right. So again, you can see this gentleman used the 0%, 7 years. Again, you know, this is basically the programs, Mass Saves programs that we're all paying for. If you buy your energy from a utility, if you ever look at that thing that says energy programs, well, guys, they're paying the banks. That's how they're doing it. They're paying, Mass Saves paying the interest to these programs and allowing the utility people to take that and use the 0%. This was about $30,000 to install. This was a complete ducted system we put in this home. This was an oil heated home, all right? And you can see the annual savings on this was around $4,000 per year. So this was a whole switch over from oil to heat pump. Let's talk about rebates in 2021. These are changing. I don't know what they are just yet. Sometimes they go up, sometimes they go down. I got a funny feeling they're going up though. So, as of today, okay, the Mass Save standard rebates for just something right out of the box is $250 per 12,000 BTUs of system. So say it's 36,000, there's a $750 rebate. That is not with integrated controls or anything like that, or with a hyperheated type unit. This is just a basic low-end rebate is what we're going to call it. You've got to be a member of one of these, okay? If you do buy your energy from a municipal, hold on because you might be on here, okay? I'm going to get to that in a second. So, this is the fuel optimization rebates. This is what I was talking about with oil, propane, electric resistance heat, things like that. So this goes up to, if you integrate this with your heating system, $1,250 per ton. So if you have a 4-ton system, let's say, 48,000 BTUs, there's a $5,000 rebate. All right, so now we're getting a little bit higher now. You do need to add integrated controls to this. There is a cost for the controls, but it's not $5,000, okay? Electric resistance heat, if you have electric heat in your home. There has to be a difference between 900 kilowatts between the sum of the winter and summer usage. All right, so we have to see your electric bill and make sure that you can qualify for that, okay? If you do buy your electricity from Eversource, okay, we can give you the rebate up front and Eversource pays us. National Grid won't pay us, but with Eversource, say there's a $5,000 rebate, we can take the $5,000 right off the cost of the job. They send us a check about 2 weeks later. National Grid has not done that with us just yet. I think we're gonna see it next year, but I'm not 100% etched in stone on that one yet. But we can take those rebates and just take them right off the bottom line, and we collect the money from them. We found it could go both ways. They could send it to you, but we find it's much easier for us to do it than we're avoiding hundreds of phone calls from the consumer saying, hey, I haven't got my rebate, I don't know how to do it, there's a little bit of paperwork involved in it, so on and so forth. So you can add integrated controls to an existing system if you already had it. That is anywhere from $500 to $1,500 depending on it. So again, these slides, we're going to give this to everybody, they'll be able to see it, but this is the actual rebates for that, okay, for the fuel optimization rebates. So that would be integrating it with your system, okay? There are programs where it's a double program if you're taking out the system. You're going to take out your oil system, and you're going to put that in. Now you might fall into what's called, I don't have it up here, but the Mass CEC program and this other program. So there might be another $2,500 in that program that might kick in too as well. That needs to get signed off on by Mass CEC. There's a little bit of things that need to be involved in that, but that can be discussed if that's something that you're looking at doing, all right? If you're looking at having a home that is being built or something, or you're doing something with that, a lot of this stuff can get pre-approved on the front end too. I don't know how many funds are left yet in that program. I don't know if that fund has been depleted for 2021. I know it was real close a few weeks ago, but it usually gets refunded the following year. So, what does it take to put integrated controls into your home? This is showing you there's a Kumu Cloud station, there's an outdoor air temperature sensor, and then there's a Kumu Cloud device that will operate the indoor units from your phone, switching it over from your boiler. We do also do this with another control now that's called IFTT, which is if this, then that, where we put a thermostat in place of where your thermostat is now. You set an applet up on your phone, and basically the Kumu Cloud and the IFTT thermostat talk to each other via the web internet temperature outside. The web says, hey, it's 30 degrees outside, puts the boiler on, puts the SOC pump on, depending on what it is. So it's an applet called IFTT. We're using that a lot now. We haven't updated these slides, but we've been using that for about the past 3 or 4 months now. It seems to be working very well. So municipals, if you're a municipal type person and you live in one of these areas, right, there are programs, all right? There's this Muni Helps program where Mitsubishi Electric is directly installed, they're directly tied in to this program. So there's $300 to $600 discounts on the equipment. When we buy the equipment for your home, we tell them this is a Muni Helps program. Depending on the equipment, we get the discount right off of it. It's passed right on to you. There's a total rebate savings of up to $1,200, or 2 single zones is $300 per heat pump, and then multi-zones is around a $500 rebate. What towns are those in? There's your towns for the Muni Helps. I don't know if anyone's from any of those towns, but they are available. It'd probably be Peabody and Marblehead would be your 2 big ones. I just did one in Marblehead, it was around $2,500 I got. This is the Abode program. This one's a little bit different. It's an awareness program. There's definitely, doesn't apply to new construction and rentals. So, next steps. I'll give you a few things of what we're doing. You can book a consultation for someone to come out to your home. We have multiple ebooks on our website that we can get you guys from today's. We have a sign up of today. We have top 10 questions to ask your contractor. We have a heating ebook, a cooling ebook. Do we have the heating and cooling ebooks here? The printed ones?
We can get them.
We can get them. And we just finished a new one, Everything You Want to Know About Air Source Heat Pumps is on our website too. So there's 4 good ebooks there for reading for some other things on that if you wanted to do. You guys will get an email shortly. We're going to try and get those out today, if not today, tomorrow, on everything that we went over. The other thing that I just want to discuss today is that, I don't want to throw it into a sales pitch, but I kind of have to, is that everyone has seen container shortages, everyone's seen what's going on with equipment. If this is really something that you are considering doing, whether it's in the spring, and you're really considering doing it, we are already being told that we are gonna see product shortages in the spring. And price increases, we're hearing of a price increase in probably January of 12% is what Mitsubishi's telling us right now. Labor shortage has been not too bad. It's not terrible right now. It's still about 6 weeks, which is out there. I've never seen it out that far with what's going on, but what we're going to offer from anyone in here today is that if someone is really serious about doing this and they don't want to do it till the spring, if you just want to get financing approved, we're not asking for a deposit, we're not asking for any down payments, we will secure equipment because we need to we're going to bring in an inventory load of equipment that we want to bring in for the spring, but we want to bring in stuff that at least we know there is a need for people's homes. You know, if it gets bought, it gets bought. If it doesn't, we know at least it's a high need thing, but a lot of people come back to us in April and May and say, yeah, I want to do this. Well, now we've got an equipment problem. We're already seeing equipment problems right now. We have a few jobs where we've just gone out and actually installed all the indoor units, but we're still waiting on some outdoor units from Thailand to hit, I think, Jacksonville maybe in the next week or two. It's been tough. A lot of stuff comes from Thailand, but they're pushing the factory to Mexico now to try to, they've converted, you know, to convert a whole line to Mexico is hard right now. So, you know, we also have a 0% for 12 months on our website. All you would need to do is just get approved on that, and we would purchase the equipment and house it here. We would keep it in here until April if need be. Because we know, you know, we don't want someone to come to something like this and then have a problem later on because it's crazy what's happened with the supply chain. And I mean, stuff that I used to pay, I looked at a price of copper the other day, a 7/8, 3/4 inch copper pipe that we used to pay like $1.25 a foot for is now like $4. $4. Insulation that goes around pipes that used to be 30 cents a foot, $2.
Wow.
It's like, the supply chain is just crazy. Even just trying to get copper, we've been struggling every week trying to get line sets and copper. It's going to 5 different distributors. You know, someone has, you know, 1,000 feet here, 200 feet here, 300 feet here. So we're just trying to bring in what we need. So I'll leave it at that. I kept it right to an hour.
Wait a minute, you gotta do the drawing.
We do have a drawing that we're going to do. Okay. I told you guys we had an Apple Watch today, and we have a $100 Amazon gift card. So thank everyone. Can't go to everybody, but
Yeah, like that, shake them around, you know what I'm saying?
okay.
Okay.
So first, I'll give you the Amazon gift card.
I have everything right here.
I'll let you pick. Huh?
The Amazon gift card.
The Amazon gift card.
Jim Grant.
Yay.
Great. Amazon gift card. Thank you.
You're welcome.
Is that Apple Watch?
This is for the Apple Watch.
Jonah.
Jonah,
Jonah.
got the Apple Watch.
Yay.
I'm gonna take a picture of you guys, if you don't mind. You okay with that?
Yeah,
Okay.
this is great.
Perfect.
So I want to thank everybody for coming. I know it's kind of like you take an hour out of your day. I want to thank you for coming. It's had a wonderful morning explaining. If you have any questions, I'm here. We have 3 comfort consultants in the back that can, if you want to turn something on, you want to hear it, you want to listen to it. If Chip, Jimmy, Dave can help you. I have any questions that need to be answered, I can hang around for a few minutes and answer whatever you need. If not, thank you, everybody.